Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at inverse functions. So let's get started. Okay guys, let's start by defining what an inverse function is. So let me define a function f from set A to set B such that f of x is equal to y, where x is an element of A and y is an element of B. Now f inverse, the function f inverse, which is represented by this symbol, this is not equal to 1 upon f. This is not equal to 1 upon f. This is not f to the power minus 1. Okay. If I want to write 1 upon f, then this will be equal to f bracket to the power minus 1. So this meaning and this meaning are totally different. Do not get confused what they mean. F inverse will be defined from set B to A such that f inverse of y is equal to x, and this exists if and only if function f is a bijective function. Only when f, what we mean by bijective is that f is a 1 1 and onto function. Only then will we be able to define the inverse of this function. Now I have put the if and only if sign here, which means that if the inverse of a function is defined, then the function is 1 1 and onto, and if the function is 1 1 and onto, then its inverse will definitely be defined. Also look here that the domain of f becomes the codomain of f inverse, and the codomain of f becomes the domain of f inverse. Let's look at it with a visual representation. Set A, set B. I am defining a function f under which x is related to y. Y is equal to f of x. Then f inverse will be defined from B to A, under which y is related to x and x is equal to f inverse of y. This is the visual representation. Let's come back to this point, why the function has to be bijective for its inverse to be defined. Let's understand it this way. If a function is many 1, it would mean that 2 or more than 2 elements have the same image in the codomain, something like this. So if I try to define f inverse, from this set to this set, elements of this set, because this becomes the domain now, so elements of the domain will not have unique images here. So that's why f inverse will not be defined if the function f is many 1. So it has to be 1 1. If a function is into, it would mean that there are free elements in the codomain. There are some free elements in the codomain. If I try to define f inverse now, this becomes the domain, and it would mean that there are free elements in the domain, which is also not possible for the function to be defined. So f inverse will not be defined if f is into. That's why it has to be onto. That means that the function f has to be 1 1 and onto for its inverse to be defined. Now how do we write, or how do we find the f inverse of a function? Let's take an example. I'm defining a function f from set R to R such that y is equal to f of x, which is equal to 5x plus 3, where x and y belong to R. Then f inverse will be defined from set R to R such that f inverse of y is equal to x. X from here can be written as, from here, y minus 3 upon 5. So x is equal to y minus 3 upon 5. So the f inverse function in terms of y is y minus 3 upon 5. Now understand the next steps very carefully. What if I write, or what if I just replace the variable y with alpha in the whole function? It becomes f inverse of alpha is equal to alpha minus 3 upon 5. It shouldn't be a problem, because what we are basically doing is keeping the meaning same. We are just changing the representation of the variable from y to alpha. So instead of writing the variable as y, we are using alpha, keeping the meaning same. That's obviously we can do that, it's not a problem. So it shouldn't be a problem if I replace alpha by t. That is not causing any problem to us. So now if I replace the t by x, we will write it this way, and it again shouldn't be a problem because I am just replacing the variable t by x. So I am just changing the representation, keeping the meaning same. But the confusion arises, and to clear that confusion I have to tell you that the x here and the x here have different meanings. They are not the same. Of course we are using x in both the places, but the meaning of these both x are different. Okay? Now why do we change y to x? Why do we do that? We do that because whenever we are writing a function, we generally take the independent variable as x and the dependent variable as y. That's why to make x, or to make the independent variable x, we are changing y to x to get the f inverse function. To summarize, to get the inverse function, we first interchange x and y, and then we write y in terms of x, and in place of y we write it as f inverse x to get the inverse function. Okay, now the graph of f and f inverse will always be symmetric with respect to the line y is equal to x, because we interchange the role of y and x. So if the graph of f is like this, and this is the line y is equal to x, then the graph of f inverse will be symmetric to this graph with respect to this line. So it will be symmetric in this way. Okay guys, so we looked at inverse functions in this video. I hope you liked the video. If you did, don't forget to hit the like button and subscribe to our channel for more great videos like these. Thank you so much.